Hello programmers. Today I'm going to show you how to program Dijkstra's algorithm using C++ and especially using vectors. Let us start. We need to include IO stream. We will be needing that for input and output functions, cin, cout and all that. Okay, so we will also include vector. Vector is almost like an array, but it's a dynamic array and it's much more convenient to use than an array. I will define some macros here. Define LLI, that is long integer. So basically I won't have to sit typing long integer at a time. I just type LLI and that's it. Then define vec_i as vector over integer. So again it's a short form, and let me just make some more short forms. Hash define vec_b, vector over booleans. Bool. And hash, no, that's pretty much it. And I'll be using the namespace std just so that I won't have to sit typing std and colon everywhere. So the main function for if anyone's any Java user is watching this tutorial, this is the main function where you guys would define it as main and string args and so on. So let's start. I will need an integer n. I'm going to ask the user to tell me their input the grid matrix size. So please input the number of nodes in the graph. End line. So I'm assuming you know the Dijkstra's algorithm and its basic principles. Alright, I'm just going to tell you how to code it. So if you haven't, just pause this video and please see some video where the Dijkstra's algorithm is concept-wise explained, and then come back to this. I'll be covering C++ programming and also be giving the parallel Java examples because it's not really that different from each other. So just hang on. So the user will now input the number of nodes in the graph. Alright, and now let me define my vectors. Okay, so vector over integer. So I'll want to make a matrix which is a 2D matrix. So what I'll be doing is vector vec_i matrix. What does this mean? This means I'm initializing a vector which stores vectors over integers. So you can imagine a vector that at position 0 it has another vector which has integers. At position 1 it has a vector which has integers and so on. So okay, so why is it important to give a space here? So imagine this vec_i. If you expand this vec_i, what is going to become of it is vector in, right? And you should have a space here, because if you delete this space then it becomes like this. So it forms this symbol, and you know what this symbol means. It's the console order of while compiling it. It's an order of pushing forward, and it doesn't make sense here, so your program won't compile. So I'll write vec_i, the short form, and I'll leave a space here. That's very important. Now I need a vector over integer distance. I'll just write dist, that's it. This will have respective distances of every every node from your desired source. Okay, now you have to input the desired source of the user. So see out here and the line just to make it clean and it looks good that way. So calculate distances from which node, example Gracia, source is 0 node ID, the first node will be 1 and then so on. So we'll need that and then end the line. Okay, and let's initialize src as that data and cin src. So from your desired sources, so just from src, because we'll be taking that input now. By default initialize it as 0. No, it doesn't actually matter. So vector over integers of distances, we need a vector boolean of visit. So it's just to keep track of the nodes that you have visited during this program. So you won't have to visit the same node twice. It doesn't make your program run double. So what we'll do is vector I dot clear. Wait, before that I'll just initialize an integer next node. We'll need that to keep track of which node to visit next. Equal to 1, because vec I dot clear, you don't want any values here. Vec, oops, I need to mention the name. So dist dot clear, visit dot clear, and now for int I is equal to 0, I is less than n, I plus plus, I will in dist I will push back 0. So I'll initialize the distances as 0. I'll also need to initialize a minimum distance integer, which I will initialize as 1, 2, 3, 4, 5, 6, 7, 8 digits, 8 nines. I'll just make it 9 nines, 9 nines. So every iteration it will check what's the minimum distance, and if the current distance is lesser than the current minimum distance, it will update the minimum distance. So I just initialize this so as to run the first iteration which I'll be writing next. So this will push back 0 and visit dot push back false, because no node has been visited yet, but I will have to set visit dot at src is equal to true, because you're not going to visit the node that you want to calculate the distance from, so that's src node, right? So you won't run that. Okay, so now we'll input the matrix. Let's see out in line. Please input matrix in table as pop. Now for int y is equal to 0, y is less than n, y plus plus. This is to run each and every row of the table, and now the next for loop is so that you travel across the rows. So r is equal to 0, r is less than n, and r plus plus. I'll have to initialize a temporary vector over integers row here, and I'll be using this vector row to push back into the matrix, into our vector matrix. So matrix dot push back row, and now shortly I'll be telling you what our matrix will look like once we do this, so just hang on. Now I will initialize a vector, and then d is equal to 0, no, not necessary, cnd, and row dot push back d. I'll just flush matrix vector here, matrix dot clear, and row dot clear. Just do this on the safe side, because some compilation errors and all, you don't want them. Row dot push back d. Now your row will have an entire row, a row at position y. So if it's at 0, it's the first row that your row vector has, and now your matrix at position 0 will have the first row. So your matrix is going to I'll show you in paint. So suppose this is your matrix vector, then you're going to have so you're going to have these rows in this vector. Okay, and now you have this position 0, 1, 2, and so on, n, and for each row vector that you have inside your matrix vector, you have these positions 0, 1, 2, and n, and at each position the distance at the table has been rightly stored. So this is how your matrix is going to look like. So something like this. Excuse my drawing. No. Okay, so that's just that. So matrix dot push back row. Now IMB dist dot at src equal to 0, because the distance of the source from the source itself is always 0. Now okay, just let me tag this loop as the input loop. Now we create a for loop in r is equal to 0, r is less than, and plus plus. Okay. You want to, every iteration of this loop, the value of min may be changed, so you want to reset that value. Where did it go? 9 times 9 it is. Copy it and paste it here. I will. Okay, so I'll need another loop here for in, say, h is equal to 0, h is less than n, h increment, and now if the minimum value is greater than or equal to distance dot at I, and visited the ith node has not been previously visited, at I is false, so it's a boolean vector, so I can just add an exclamation mark over here. If this, then I want minimum to be set to distance dot at I, and I'll be doing visited dot at I is equal to true. So sorry, why am I writing I? It's supposed to be at. No, it is I. I'm sorry. No, it's supposed to be h over here. So let's just quickly change it. Oh, and I forgot one important thing. Once I have finished inputting the matrix, then I'll have to initialize the distance vector. Distance is equal to matrix dot at src. This is because we'll be initializing this distance vector to all the distances values at the srcth row. So basically you have a vector of distance of node 1 from src, node 2 from src, and so on, dot dot dot. So this is what it does. So distance equals matrix dot at src. Now minimum is equal to distance dot at h, and visited h is equal to true. Now let me just, okay, and we'll be wanting to change this visited only if this it's not previously visited. So let me do next node is equal to h, or only if this condition is matched. So I won't be doing h over here, so it won't run on every iteration, only those iterations when this condition holds true. So at h at next node is equal to true. Don't forget the semicolon. Now I want a for loop here. In j is equal to 0. So let's take something different. Int s is equal to 0, s less than n, s plus plus. Okay, now if you have not previously visited visit dot at s, so I will do an exclamation mark here, not visited, then if your minimum is minimum plus distance, sorry, minimum plus matrix dot at s dot at next node dot at s, that is In other words, what you'll be writing is, in case of an array, would be matrix next node and s. So I've just written this the way you write it for vectors. So if this distance is greater than distance dot add s, then what you want to do is you want to set this distance to the distance. So assign the value of distance dot add s. Oops, I want it the other way around. So erase this, copy, sorry, cut, equal to, and yeah. Now, okay, now our program is more or less ready. Now let me just find where the main terminates. Okay, here, so the final one. Now I want to output the values that we have found using the Dijkstra's algorithm. And what I'll do is I will create a loop for integer c equal to 0, c is less than n, c++, wow, c++, okay, c out, in line, distance of node c from src is distance dot add c and line. Let's compile it and find any errors. Dijkstra tutorial save. Okay, syntax error. And okay, min is greater than or equal to what was here. Okay, this dot add fetch right. Okay, compile. Visited was okay, it's visit, compile, spelling, dist, compile, no errors. Okay, so now let's try compiling it again. Yes, done. So we'll now run it. Before that, I'll just in Paint try to visualize what our matrix will be like. So say this is node 1, sorry, 1 right here. This is 2, 2, this is 3, and now you have lines joining these. You have lines joining these nodes. Let's say the distance here is 4. I'm sorry, someone came in the room. So I was saying 1 to 2 is 4 units away. 2 to 3, let it be 7 units away, and 1 to 3, let's say 2 units away. Okay, so now let's try to visualize our input. Number of nodes is 3. Distance I want it to be calculated from the source, that is 1, 0. Okay, so 1 to 1 distance is 0. 1 to 2 it's 4. 1 to 3 it's 2. 1 to 2 again it's 4. 2 to 2 is 0 with itself, and now 3 and 2 it's 7. 1 to 3 it's 2, here it's 2 to 3 7, and 3 to 3 with itself it's 0. The distance of node 0 from 0 is 0. Node 1 from 0 is 4. This is node 1. See, this is 0, this is 1 and 2 in computer language. So 1 from 0 is 4, and node 2 from 0 is 2. So there's a Dijkstra algorithm presented to you in C++. For any questions, comment below or email me. Thank you. Present, oops, it's on green here, from 28, presented to you by hello Satay. Thanks. Now don't save it, just delete it.